Okay, welcome one and all. So this is the third lecture in the average, the concept of average. Now this question, actually I have already discussed this question in the second lecture, actually at the end of the second lecture. So here I mentioned that this question can be solved in multiple ways. So one way I had already discussed in the lecture number 2 at the end of the means the last question which was discussed in the lecture number 2 on average. It was this question. And I discussed that in this example, basically there are two types of expenditure. Here, this thing is somewhat, we can say, special about this question that to identify the expenditures here. Okay, so I repeat here, this is important that what type of expenditures are there. Okay, so here there are two type of expenditures. One is expenditure per head or per student. One is expenditure per head or per student. The symbol I will use it is EH. Okay, and EH means expenditure per head. And there is another expenditure which is expenditure per day, and symbol I am using it is ED, the expenditure per day. Okay. Now, what is the relation between these two expenditure? The relation is that expenditure per head, the expenditure per head, it is nothing but the expenditure per day divided by number of heads. Okay, now we can understand that what is the meaning of these two. Okay, so we can write in this way that expenditure per head, it is nothing but this. So now in the previous lecture, how I have solved this question, I have assumed this one expenditure per head as X, this as X. Okay, so that's why we will have two values of this expenditure per head. I repeat, in the previous lecture, I had assumed this expenditure per head as X. Okay, so that's why we will have two type of values of expenditure per head. One will be the original, O stands for original expenditure per head, and another one will be NEH means new or new expenditure per head. Okay, so let this be X. Okay, the original expenditure be X, and obviously this will be original expenditure per day, okay, and divided by original number of heads or students. Now this we don't know, but we know that this was the original number of students or heads. And now what is this X minus 1? Obviously this is new expenditure per head. How it is X minus 1? Because it is given in the question that the average expenditure per head, you can read that average expenditure per head, it diminished by rupees 1 when the 7 new students they were added. Okay, so that's why this is the new expenditure per head. So this X minus 1, it is nothing but the new expenditure per day. The new expenditure per day divided by new number of heads. This NNH, what is the meaning of this NNH? New number of heads or students. And obviously this is 42 and this numerator is unknown here. So now from the top equation, what will be this original expenditure per day? The original expenditure per day, actually it will be 35 multiplied by X. Basically what we have X equal to original expenditure per day divided by original number of students. So what will be this thing? It will be nothing but 35 into X, which is here. And similarly, the X minus 1, the new expenditure per head, it is nothing but this new expenditure per day divided by the original, new number of heads. So what will be this new expenditure per day? It will be 42 times X minus 1. So we have these two expenditures now. Now it is given in the question that due to the admission of 7 new students, the expenses of the mess were increased by 42 per day. Okay. So what is the meaning of this? That this new expenditure per day, it is 42 more. This new expenditure per day, it is 42 more than this 35X. Okay. So if I have to put these two equal, then either I should subtract 42 on this side, on in this side, or I should add 42 on this side. So basically, I had added 42 on this side. Okay, so that's equal to 42 x minus 1. And when we solved this, our x came out to be 12. Okay, so what was this 12? Actually, this was original expenditure per head. This was the original expenditure per head. So if this is the original expenditure per head, what will be the original expenditure per day? The original expenditure per day, which was asked. So that will be nothing but this 35 into 12. This will be 35 into 12. One can very well see from here. So solving this, obviously, this is for 420, and option C was correct. And one can verify his answer also, because if 12 x equal to 12, this is the original expenditure per head, then what will be the new expenditure per head? This x12, this is the original expenditure per head. Okay, so this is original expenditure per head. So what will be the new expenditure per head? That will be nothing but 11. Okay, so what will be the new expenditure per day? The new expenditure per day. So new expenditure per day. So here NED, new expenditure. Obviously, it will be nothing but 42. Okay, because the new number of students into this 11, the new expenditure per head. So if you calculate this, then obviously it will be 2. First, I will write 2. Then 4 plus 2, 6. One can very well see. First, write the unit digit 2. Then 4 plus 2 is 6. Now, next to 4, it is 0. So 4 plus 0, it is 4. 462. Actually, this is the way how to multiply a number with 11. Okay. So I had just explained that how to multiply any number by 11. Okay. So first we write the unit digit. So first I have written 2. Then 2 plus 4 means unit digit plus 10 digits. It is 6. Okay. Now 4 means in front of the 4 it is 0. The hundreds digit it is 0. Okay. So 4 plus 0 it is 462. So this is our new expenditure per day, and one can very well see that this 462, it is 42 rupees more. This 462, it is 42 rupees more, okay, than this 420, which was the original expenditure per day of the mess. So here one can verify our answer. And just an example that how to multiply any number by 11. So for example, if I have to multiply say 789 with 11, 789 with 11. So first of all, I will write 9, this unit digit. Okay. Now 9 plus 8, it will be 17. The 9 plus 8 is 17. So 7 I will write unit digit and 1 will be carryover. Okay. Then 8 plus 7, 15. 15 and plus 1 this carryover. So it will give me 16. Okay. So now I will write 6. I will write 6 and once again 1 for carryover. Now here it is 0. Now 7 plus 0 is 7 and this one carryover means 8. Means 789 when multiplied by 789 when multiplied by 11, the answer will be nothing but 8679. Okay, so this is just a help to multiply a number with 11. So this is the one way that I had already discussed in the previous lecture. Now I will discuss the another way to solve this question. Okay. So let us discuss the second way to solve this question. So in previous method, I had assumed this expenditure per head as X. I had assumed this as X. Now here I will assume that this expenditure per day, it is X. I repeat, earlier I had solved this question by assuming this as X. Okay. So that's why there were two values. One was original value of expenditure per head, and there was another which was new value of expenditure per head. Now here I will solve by assuming that expenditure per day, let it be X. So that's why we will have two values of this expenditure per day. Okay. So the original expenditure per day, let it be X. Okay. So this is the original value. And then there will be new expenditure per day. The new expenditure per day, that will be X plus 42. Okay. So here, why it is X plus 42, it is mentioned here. Okay. So now, once again, using this equation, we will have this because this original expenditure per day, it is X now. So this is X by 35, original expenditure per head. And obviously this one new expenditure per head, it will be new expenditure per day divided by new number of heads. Okay. And obviously this is 42 plus X and divided by this is new number of heads or new number of students, that is 42. So basically we have these two, that original expenditure per head, which is nothing but X by 35. And we have new expenditure per head, which is nothing but 42 plus X by 42. Okay. Now, it is once again, if we go by the statement that this average expenditure per head, this average expenditure per head. Okay, so since it is average here, so that's why we can understand average. What is the meaning of average? So we can, I can or we can add one more word this side, which is average expenditure per head. Average expenditure per head. Okay. So here the average is majorly about expenditure per head. Okay. So here we have these two. Now this one, this new expenditure or new average expenditure per head, it is one less. This one, it is one less this original. So that's why if I have to put these two equal, means these two equal, then either I should add one this side. Okay, if I have to put them equal, or if I am not adding one this side, then I should subtract one this side. Okay, so I will move on by adding one on the right hand side. So X by 35, that is equal to 42 plus X by 42 and plus 1. Now here to solve, I will multiply the two sides by 210. Multiply the two sides by 210. What is this 210? It is nothing but the LCM of 35 and 42. Actually, what is 35? It is nothing but, okay. So what is this 35? It is 7 into 5. And what is this 42? It is 7 into 6. So what will be the LCM of these two? It will be 7 into 5. Actually, we may write here it is 7 into 2 into 3. So this will be 7 into, okay. So 7 into 2 into 3 into 5. So 742. This one 7 to 40, 42, 42 into 5, 210. Okay. So yeah, one can verify also that this 42 for so 5 to 10s and it is 210. Okay. So multiply by 210. Now, when this X by 35 multiplied by 210, it will simply give us 6X. And when this one, it is multiplied by 210, it will give 5 time. 5 time of what? 42 plus X. Okay, so this is the bracket. And when then 1 is multiplied this by 210, so this is 210. Now here it is 6X. Okay, actually this is equal to 5 into 42. Okay, and plus 5X, that is plus 210. So from here, what we will get, that actually C 6X and this 5X, it will come to this side. So 6X minus 5X, it will be X. And what is 5 into 42? We had just done. So it is 210 and plus 210, and that gives our 420. And this was the answer. Obviously, why? Because X, what is X here now? It is the original expenditure per day. This is the original expenditure per day. Okay. So let's go back to our, okay. So you can see this X. Okay. And that's why this is the answer here. Okay. So this was the second method of solving this question. So now this question is homework for you. Okay. Homework. Okay. So it will be good if someone solve this question and put the answer in the comment box. Okay. Okay. Even this question I had discussed in the previous lecture, but in that lecture I had discussed from a different approach. Okay. Now I will discuss it with a different approach. Actually, in previous lecture, I have discussed with the approach of batting average. I had solved this question with the approach of batting average. Now here I will discuss it with the meaning of the average. So what is the meaning of the average? So average, actually it is a number, okay, which can be equally distributed, which can be equally distributed, distributed among all the members, among all the members. So this is the meaning of average of a certain number of members. So here, suppose we have 1, 2, going on up to 59 and 60. So we have originally 60 students and their suppose average weight be X. The average weight be X. Okay. So here this was the average weight that we are assuming. So X, this is the, we can say this is the original average weight, original average weight of 60 students. Okay. So this is the average weight, means we can assume that all of the 60 students, they have average weight 60. So sorry, all of the 60 students, they have average weight X kilogram. Okay. But it doesn't mean that every student, it's exactly the individual weight. Okay, the individual weight of each student, it was exactly equal to X. Okay, the individual weight will be different. But yes, we can assume that this X, it can be equally distributed among all the 60 students. Now, suppose this 60th student, suppose this left the class. Now, what was the individual weight of this 60 student? Actually, this was 45. Okay, the individual weight of this 60 student, it was 45. Now, once this student, it leaves, then the remaining average, actually it increases by 200 gram, means it is now x plus 0.2, x plus 0.2. Why it is 0.2? Because 200 grams converted into the kilogram, so divided by 1000. So obviously this is nothing but 0.2. Okay. So the average of remaining 59 students, it is increased. Now, what is the meaning of this thing that the average is increased? It means that this 45 means the individual weight of this 60th student who left. Actually, it must be less than X, the earlier average. Okay, the original average. Okay, because since this weight was less than the original average, so that's why once the student left, that's why the average has increased. Okay, and suppose if the this 45, it was greater than, by chance if it was greater than the average weight. Okay, then in that case, if the student leaves, then the average would have decreased. Okay, so this one can very well feel. So now here this difference of x minus 45, since 45 is less than x, means x minus 45. This is the difference created. Okay, so this difference in the weights. Okay, now this difference, it will be distributed equally among remaining 59 students. Okay, means this x minus 45, this difference, why actually this difference is created. This difference is created because this 60th student whose weight was 45, this left. So this difference is created. Okay, the difference in the weights. Now this difference, when equally distributed, okay, when equally distributed among the remaining 59, it will give us the change. It will give us the change in the average. Okay, so this one can feel easily. So basically we have to solve this equation. So we have nothing but x minus 45, which is equal to 59 into 0.2. Means what will be x? It will be 45 plus 59 into 0.2. Now, if one solves this, so 59 into 0.2. So if I'm not wrong, so this will be 2, 9, 18. So 2, 5, 10, 11. So it will be 56.8. So this x, it will be 56.8. Okay. Now, this 56.8, this is the this was the original average weight of the 60 students. This was the original average weight of the 60 students. But here we are asked that what is the average weight of the remaining 59? So for remaining 59, this 56.8, okay. So this is the average now. So this x is 56.8. So means the remaining 59 students, their average was zero point 0.2 more. It was increased. Okay, so 56.8 plus zero point 0.2, it will be nothing but 57 kilogram. Okay, so this is the another way to solve this question. Okay. So even this question I had discussed in the previous lecture. So here I will discuss in another way. Actually, this question, it can be solved by the concept of weighted average. It can be also solved by the concept of a weighted average. Actually, this will be given by N1A1 plus N2A2 divided by N1 plus N2. Okay. So where, what is this A1? Actually, this is the average. This A1, this is the average of N1 number of things. Okay. And what is this A2? This is the average of N2 number of things. So here weighted average, if I denote it by WA. So what is this WA? The third average. This is the average of N1 plus N2 plus N2 number of things. So basically here three averages are involved. Okay. And in the previous course, means in the previous lecture, I have solved this question by the method of alligation. The method of wait. So here allegation. So actually, I discussed that or mentioned that the concept of allegation and average, they are related. How they are related, the concept of allegation and average, how they are related. If in a question, in an example, if three averages are given, if three averages are involved, okay, directly or indirectly, then we can apply this method of allegation. Okay, so now one can very well see here we are already having three averages. One is A1, another one is A2, and another one is this weighted average. Okay, so here further, what is this A1? We may say this is the sum of the N1 number of things. Okay, so A1, it is sum S1, sum of N1 number of things. And what is A2? Actually, sum S1 divided by N1. Where what is this S1? It is sum of N1 number of things. Okay, N1 number of things, and divide by obviously N1. So here A2, it is the S2 upon N2. Okay, so what is this S2? Obviously, this is the sum of N2, the N2 number of things or observations, you may call anything here. Actually, we will take as per our example. Okay, so this is our A2. Now here, in this question, what is our A1? A1 is nothing but this 12.4 runs per wicket. Okay. So this 12.4 runs per wicket, this is our A1. Okay. And what is our A2? Actually, A2 will be given by here. It will be from here. Means the average in the means the bowling average in the last match. Okay. So what was A2? So this A2 was from here. Obviously, this will be 26 by 5. Okay. So this was 5.2 if you recall back. Okay. So here, this is our A1. Okay. Now here, A3. A3, it is nothing but the total, the combined weighted average of all the 13 matches. So A3, or we can say this WA. Okay, this WA. So this will be the weighted average of all the combined 13 matches. How? Because what is our N1? Actually, N1 is to be calculated here, but here, what is the meaning of N1? So just wait. So here, the N1, it is the number of wickets. It is the number of wickets taken. Okay. Up to the last, means up to the last match means taken originally. We can say originally. Okay, and what is N2? It is number of the wickets taken in the last match. Taken in the last match. Okay, means what is N1? It is number of wickets taken just one match before the last match. Okay, and N2 is this. And now, what we need? We need this the WA weighted average. So, what will be weighted average? So this one weighted average. So it will be N1. N1 actually this is not known. We don't know that how many wickets he has taken originally, means up to the second last match. Okay, so it is N1. And what is A1? A1 it is 12.4. And what is N2? The number of wickets taken in the last match, it was 5. Okay, so this was 5. And what was the A2? A2 obviously it is 5.2. The average was 5.2. And divide by what? Divide by this N1 plus N2. The N1 plus N2. So obviously what is this thing? It is A1. Okay. And this is A2. And now what is this weighted average? Means the combined average, okay, or the weighted combined. Yeah, this there is another word which is combined. Means this is also known as combined average. Okay. So what was this combined average? Actually, now it is 12. The combined average of the N1 plus N2 number of wickets, it is 12. How it is 12? Because it is mentioned in the question that due to the performance in the last match, due to this performance, this performance in last match, the average is reduced or improved by zero point 0.4. Okay, so here now that's why it is 12.4 minus zero point 0.4, that is 12. Okay, and please mind, I have discussed that what is the meaning of improved here. Okay, so in case of bowling average, if in the case of bowling average, if it is improved, means if a bowling average is improved, then we will subtract this improvement. Okay, so even this I had discussed in the previous lecture in well detail. Okay, so do watch. So that's why now we have to solve mainly this equation. Okay, so this is solving this. It is not that typical. So means it will be 12 and 1 plus this 60. Means this and 1 plus 5. It will go to this side. Okay, and this side we have 12.4 into N1. And what will be this 5 into 5.2? Obviously, it will be nothing but 26. Okay. And now we have nothing but this 26 will come to this side. So it will give us 34. Okay. And this 12 and 1, it will go to this side. It will give us zero point 0.4 and 1. Okay. So obviously what is N1? It is 34 divided by zero point 0.4. So this is 34. Here it is 4. Obviously I will write 10 here. So here it will be 2, and here it will be 17, here it will be 5. So this 17 into 5, it is 85. Okay. So this is N1, 85 number of wickets. Okay. So this 85 number of wickets, it is up to the second last match, means the number of wickets originally taken originally. Okay. This was the taken originally. And in the last match, it is 5 more. So 85 plus 5. 85 plus 5, 90. Okay. So here the option C will be correct. Okay. The option C will be correct here. Okay. Then I had discussed one more question, which was nothing but this. Even here, we can apply the same concept. So what is this 11.1152 runs per wicket? It is our first average. Second average will be coming from here, means A2. Okay, it will be from here. So what will be A2? A2 will be 38.5 divided by 7, which will give us 5.5. Okay. And Obviously, what is the A3 or the weighted average? A3, the third average, or we can say the weighted average, or we can say the combined average of all the matches. Okay. So that will be nothing but 10. Okay. So now that's why this 10, it will be equal to N1 into 11.125 plus N2. What is N2? That we know 7 number of wickets taken in the last match and into 5.5 and divide by N1 plus 7. Okay. So what is this 10? It is the weighted average or combined average. So this is the weighted or combined bowling average. Obviously, here it is bowling. The average is bowling average, but up to the last match. Okay, means in the total matches, we can say in the total matches or total innings. Total matches or total innings. And what is this N1? It is a number of wickets taken. Okay, because obviously here how we are calculating the bowling average, even I have discussed this in previous lecture, that bowling average, this is nothing but the number of runs conceded. Conceded means given by the number of runs conceded by the bowler divided by the number of wickets taken by the bowler. Okay, so that's why we have this equation. So N1, it is the number of wickets taken. Okay, originally, originally means before this last match. Originally means before this last match. And this is the number of wickets taken. This is N2. Okay, this is wait. Yes. So here it should be N2. Yeah, this is clearly N2. So number of wickets taken in the last match. So this is the corresponding averages and obviously this one. And now N1 plus 7. So this is now 10 N1 plus 70. You can see this going to this side and this is now 11.125 N1. And obviously this is once again 38.5. So now just shifting this to this side and this to this side. So obviously 70 minus 38.5, it will give us 31.5. And then we will have 1.125 and 1 and 1. So this will imply that N1 is given by N1, this will be 31.5 and 1.125. So now it is just merely some calculations. Okay, so here it will be 1,000. Here it will be 10. So this will cancel out. So here 5, we can cancel out 5, 6, and 3. Here once again this 2, 2, 5. So actually now 9, 7, 63 and 9, 25. Okay, so 25 and 4. So here 7 into 4. 7 into 4, this is 28. So 28 number of wickets were taken originally. Okay, so 28 number of wickets were taken originally. So 28 plus 7, that becomes 35. Means the wickets, total number of wickets taken by the bowler till the last match. Okay, so this one. Now, even these questions I had discussed in previous lecture. Okay, means in the lecture number 2, and I had discussed in very much detail, means start from the very basic, and then starting from the basic and discussing it with the shortcut technique. So the shortcut technique was this, that here in the case of average up to 13th inning, so here I will subtract the total improvement up to 12th inning. Here to find the average of the batsman up to 13th inning, I will subtract the total increment or total improvement up to 12th inning. And I will subtract this from where? From the 97, the performance in the last match. Okay. So that was This was the average up to 13th inning. And by chance, if I need the average up to 12th inning, then once again I will subtract. Once again I will subtract the total increment, but on up to 13th inning, up to the 13th inning. Okay. So, but again I will subtract it from 97, the performance or runs in the last inning, and that will give us the average. But this will be the average or batting average. The it will be the batting average, but up to the 12th inning. It will be up to the 12th inning. Okay. So this I had discussed in very much detail. One remark in that discussion, please note down. Actually, this one, the first one entry or first one number, actually I should have told in the way that this is also an average. Means this the performance in the last match, even it is also an average. How it is average? Because this is 97 divided by 1. 97 divided by 1. Now it becomes average. So this is the average in the last match or last inning. Please mind. So I missed this one, and I had mentioned in the comment box also that in such questions, the very first number means the runs scored in the last match. It should be viewed as, or it should be taken as average. How? It is 97 divided by 1, the number of innings played. Okay. So this remark was there. It was missing there. Okay. Now here, I will solve it by allegation method, means the alternative way. So actually, these questions, they can be solved by allegation method also. But there we have to take care of a certain point. What is that point? I will discuss. So here, let X be the average. Let this X be the batting average. So this is the batting average up to the 12th inning. Suppose it is up to the 12th inning. Okay. So here it is X. Okay. The one average. Now in the last match, the average is 97. Okay. Because this is 97 by 1. Okay. And what is the combined average of 13th match, the 13 matches? The combined average of 13 matches, obviously it will be X plus 5 as per the statement. Okay. So now again we have three averages involved. Okay. So here, as per the method of the allegation, we need the difference here. So the difference of x plus 5, it is 5. Okay. But please mind, if you go through the previous lecture, I told you that here we have to take, that here we have to take only the positive sign. Okay. So here, that's why it should be modulus of x minus 5, the modulus of x minus 5. So that's why x will go off. So minus minus is plus, and what is modulus of 5? It is 5. Okay, yeah, sorry, it should be x plus 5 here. So here it will be minus 5. Okay, so minus 5. So what is modulus of minus 5? 5. Okay, so I had mentioned in the same way in the previous lecture that here we have to take the modulus. Okay, the modulus of, say this is A1, the modulus of A1, and this is A3. So here it is the modulus of A1 minus A3. So what is the meaning of modulus? Means we have to ignore the negative sign. Means we will take only positive sign. Okay. So this is A3. Now, even here, so if this is A2, then what I need the modulus value of A2 minus A3, means the positive value of this. Now here's something important is there, which must be noted down very carefully. Okay. Now what is the modulus here? So modulus here, it will be x plus 5 minus 97. Okay. So this is now x minus 92. X minus 92. Now here, actually, since our average has increased, the average has increased. So that's why this X means this X, which is the batting average up to the 12th inning, which is the batting average up to 12th inning. It must be less than this 92. This must be less than 92. I repeat, since the batting average has increased, Okay, this X, actually this batting average, it has increased by 5 due to the performance in the last match. Okay, so that's why this X must be, means the average up to 12th inning, it must be less than 92. Okay, so since it is less than 92, means 92 minus X, it will be positive. It will be positive. So this modulus value, okay, so this must be taken as 92 minus X. Okay, so otherwise, if someone takes it as X minus 92, means this plainly simply as X minus 92, then he will get wrong answer. Okay, so this method, one may leave this method, there is no issue. I have discussed with the another way, with the very simple way in the previous lecture. Do watch. But if someone can very well understand this concept, then he can go by this way also. Okay. So now what we have this 92 minus x, okay, which is nothing but this a2 minus a3. And we have this 5, which is a1 minus a3. So this is basically ratio, this 92 minus x and 5, this is the ratio. Ratio between what? The ratio between the number of innings. Okay, so I mentioned that that when we do this thing, that a2 minus a3 and a1 minus a3, this is the ratio of the denominators. This is the ratio of the denominators which are associated with a2 and a1. Okay, so here what is our denominator? Actually, even if I talk about this one, that what is A2, it is 97. So 97 by 1. So what is this 97? It is the total number of runs in the last match. And what is this? It is number of innings. Okay, number of innings in the last match. Obviously, in last match, it is only one inning. Okay, so here in the denominator, what we have? Number of innings. Okay, so this 92 minus x ratio 5, it is the ratio between number of innings. Okay, so 92 minus x, this 92 minus x, which one can see, which is a2 minus a3. This is the number of wickets, oh sorry, number of innings, this 92 minus x. This is the number of innings which are associated with a1, this side, a1. Okay, so up to a1, how many innings were played? 12. And what is this 5? This 5. Okay, so this is the number of innings which are associated with A2, 97, which are associated with A2, 97. So here, obviously, how many innings are played here? It is only one. Okay, the one inning played. Now we have to merely solve this. So 92 minus x, it is 12 into 5, 60. Actually, just cross multiply. Okay. So now from here, what will be x? X will be nothing but 32. Okay. So this is the batting average up to 12th inning. The batting average up to 12th inning. And what we need the batting average up to 13th inning. Okay. So up to 13th inning, obviously it will be 32 plus 5, that is 37. Okay. So this is the another way, means by the way of allegation. But here, yes, we have to be very, very, very careful that we have to take the positive sign of this difference. Okay. A1 minus A3 or A2 minus A3. So this was just for some extra method, and one can try this question also. So here the score was 36 runs in the last match, due to which the average is reduced by 3 run, and we have to find the batting average up to 18th inning. Okay, so here if I directly talk about the shortcut that I discussed in the previous lecture, so here since the average is reduced, so here I will add the underperformance, the total decrement. Okay, here I will add the total underperformance or total decrement, but up to 17th match. Okay, why? Because it is here 18th match. So here 17 into 3, this is the total decrement. Okay, up to 17th match. And I will add to what? 36. Okay. So this will give us our answer. And if by chance instead of 18, if we have 17th inning, means we have to find the average of batsmen up to 17th inning. Then I will add the total increment up to, sorry, total decrement up to 18th inning. Okay. So here this 3, it is the decrement in one inning, and this 18 into 3, it is or 17 into 3. This is the total increment up to 17th or 18th inning. But again here I will add up to 36. Okay, add to 36, and that will give us the answer. And once again, this 36, this first entry 36, it should be viewed as or taken as the average. Average in the last match means 36 divided by 1. Okay, so this remark was missed here. So even this question, it can be solved by the same way. Okay, so here what will be the way of solving by allegation? So here say x is the batting average, the batting average up to the 17th inning. Okay, so here x, then last match it was 36, actually 36 divided by 1. Okay, and now here it was decreased, so x minus 3. Okay, decreased by 3. Now here what is the difference? I should take 3 here, and this side actually it should be x minus 3 minus 36. Okay, modulus value, so this will give us x minus 39. Now we have to consider this sign. Now here, since the batting average has decreased, okay, so the batting average has decreased means this x, okay, the batting average up to 17th inning, it must be greater than 39, means x minus 39, it is positive, so we should take it as such, means here I should write x minus 39. Now this x minus 39 and 3, they are the ratio. X minus 39 and this 3, they are the ratio between the number of innings played up to 17th inning and up to the last inning. So this ratio, this is the ratio of between, this is ratio between the number of innings played up to this x average and up to this average. So now up to x average, how many innings were played? 17. And up to this average, how many innings were played? 1 only. Okay, so just cross multiply. Okay, so we will get x minus 39, that is 17 into 3. So x, it is nothing but 39 plus 17 into 3. So if you calculate, this is 39 plus this 51. So it will give us 915390, means this is the batting average up to 17th inning. This is up to the 17th inning. But what we need up to 18th inning. So up to 18th inning, the average has reduced by 3 runs. Okay, so that's why 90 minus 3, that will be 87. So here that's why the answer would be 87. Okay. Similarly, this question one can try. Actually, I had discussed in previous lecture also. So here it is for practice. So one can follow any method in which he or one feels comfortable. Okay. Actually, one can solve this type of questions also with the earlier discussed techniques. So here we can assume let x be the average. Okay, the batting average up to the 13th inning. We can assume it up to 13th inning. Okay. So here the average up to the 15th inning, it has increased by 2. Means this x plus 2. This is the average up to the 15th inning. So this is the average up to the 15th inning. So in a certain sense, this is nothing but the weighted average. Okay, so here x plus 2, it will be nothing but N1A1 plus N2A2 and divide by N1 plus N2. Okay. So here, what is N1? N1 is the number of innings played up earlier, means it is 13. Okay. And A1, what is A1? A1 is the average up to the 13th inning. And what is N2 here? It is 2. Okay. So I am writing. So here it is 13 and here it is X. Now it is and two more matches are played. And what is the average here? Actually, average is nothing but 60 plus 30 divided by 2. Actually, it is 45. Okay. So, but actually 2 into 45, again, it will give us 90. And divide by 13 plus this 2, actually 15. So this is 15 now. Okay. So this is 15. So this 15, obviously, it will come multiplied by this side. So this will give us 15x plus 30. So that is actually 13x. And this is 90 now. So here we have 2x, just shifting the term. So here it is 60. So what is x here? X must be 30. Okay, means the average up to 13th inning is 30. And obviously, since it has increased by 2, so that's why the average up to 15th inning must be 32. Okay. So there is one more question here. So this one, it is now homework. Okay. So please solve, and it will be really appreciable if one solves it and post the answer in the comment box. So this is one more question. Obviously, I have already remarked that such questions, they can be solved by multiple ways. Here I will solve it by the way of deviation method. Okay, the deviation method. Okay. So here, the average marks of the Radhika in seven subject is 75, and average in six subjects is excluding science, it is 72. Means here in six subjects, the average marks were 72. And there is one more subject, that is science. And so obviously what we need here, how many marks in science she has. And what is the overall average of seven subjects? 6 plus 1, it is 75. So, as per the deviation method, so what is the difference between this 72 and 75? It is 3. Okay, this difference is 3. And what is the total difference or deviation? Actually, deviation or difference between 72 and 75 is 3. So, what is the total deviation for these six subjects? It will be 6 into 3. Okay, 18, and obviously I will put negative sign also because it is less number of marks. Okay, means these six subjects, they have they have 18 number less. They have total 18 number less as compared with this 75. So obviously this minus 18 marks, means these minus 18 marks, they will be compensated by this X. So what is X? X is nothing but the marks, Radhika's mark in science. Okay. So obviously these minus 18, they will be compensated by this X. Okay. So X must be 75, means X it must have 75 value minimum plus something more. What is that more? It must be 18. Okay. So this is the compensation. Okay. The compensation made by the marks in science. So obviously now the answer will be 93. Okay. Means Radhika must have marks 93 in science. So this method, deviation method, even this method I have discussed with a very good example. Actually, this deviation method I have discussed with a very basic example, very interesting example in the lecture number 1, and the cricketing, the batting average or the bowling average questions I have discussed with good example in the lecture number 2. So one can watch those lectures. So here, this question, the average speed of a train running at a speed of 30 kilometer per hour during the first 100 kilometer, at 40 kilometer per hour during the second 100 kilometers, and going on 50 kilometer for the last 100. Okay. So we need the average speed for the whole journey, the average speed for the whole journey. So here we will apply this formula. Okay, so if a person covers three equal distances at a speed of a kilometer per hour, b kilometer per hour, or c kilometer per hour, then the average speed for the whole journey it will be given by this. So what is A here? This 30 kilometer per hour, this is our A. This 40 kilometer per hour, it is our B, and this 50 kilometer per hour is our C. Because in here, the person is covering equal distances. Okay. So what will be the required average speed for the whole journey? The required average speed for the whole journey, it will be nothing but 3 times this 30 into 40 into 50 divide by AB. Now, what is AB? 30 into 40. So that will be 120 plus BC. What is BC? It will be 40 into 50. That will be 200. And what will be AC? That will be 30 into 50. That will be 150. Okay. So now here we have some calculations only. So it will be, we can write here 3 into 30 into once again. Actually, okay. So I am cutting, means I am writing here. So 40 here, 50. And now this one, it will be 0, then 257 and 12470. Okay. So now this we can cancel out. And now there will be no more cancellation possible because 47 is this 47 is a prime number. Okay. Okay. Actually, I had made a mistake when I was writing these values. This is AB. This is BC and this is AC. So I made a mistake. So actually A into B, it will be 1200, not 120. Means this value will be 1200. Similarly, here it will be 2000. Here it will be 1500. So that's why there will be one more zero. Okay. So here now we can cancel out this zero and even we can cancel out this zero. So that's why now here it will be 360. Okay. So that's why here it will be 360 multiplied by 5, and that's why it will be 1800 divided by 47. So if one calculates, it will come out to be 38.29 kilometer per hour. Okay. So that's why the approximate will be 38.3 kilometer per hour. Okay. Obviously here it is asked nearly. There is one more formula here. At present, I don't have any question based upon this. Okay. Suppose if a person covers P distance or P part of his total distance with speed X, Q part or part of his total distance, okay, with a speed of Y, and R part, okay, with a speed Z or Z, means P distance with this speed X, Q distance with this speed Y, and R distance, R amount of distance with speed Z or Z. Then the average speed is given by this X, Y, Z, Z, P, Y, Z, P, Q, R. Okay. So even this formula is there. And actually how to, we can, what is the pattern here? So here I will write P, Q, R, and here it will be X, Y, and Z or Z. Okay. So obviously in the numerator it will be X, Y, Z, means the product of the speeds. Now in the denominator, okay, so for the denominator, this P, it will be multiplied with Y and Z, means P will be with Y and Z. Then plus Q, Q, it will be multiplied with X and Z. P will be with Y and Z, Q will be with X and Z, and R will be with X and Y. Okay. So this is the formula here. So this is another type of question in average. So here a motorist has traveled to he has to travel a place 150 kilometer away at an average speed of 50 kilometer per hour and returns at 30 kilometer per hour. So his average speed, what will be his average speed for the whole journey? Actually, the formula is given by this, that it will be 2xy upon x plus y, where what will be x? X will be the speed from A to B, from one point to the another. And what will be y? It will be the speed from B to A. Okay. So here, the answer of this question, it is plain, because here what is our x? X is nothing but 50 kilometer per hour, and what is y? It is nothing but 30 kilometer per hour. So our required answer will be 2 into 50 into 30 divide by 50 plus 30. Okay. So now obviously we will have here 2, this 50 plus 30, this is equal to 80. So now for this 80, we can cancel out this one. And now even here we can cancel out this 4. So even for this 2, we can have this 25. So 25 into 3, it is 75. 75 divided by 2, it will give us 37.5. So option C will be correct. Actually, we can drive this formula also. How we can drive? The formula is the basic formula used is simple, that the speed is equal to, it is distance divided by time taken, the distance traveled by time taken. Okay. So here, suppose from one point to another point, the distance is d. The distance is d. Okay. So here, and the time taken, say it be t. So here the speed, this is x. Okay, this is the x from A to B. So here we are taking 2 points. Say one point is A and the another point is B. So here this is the speed, okay, x kilometer per hour. And what is the total distance? So this is the x kilometer per hour. This is the speed from A to B. And this total distance between A and B, I am taking it as d kilometer. Okay. So here the formula is this one, that speed is nothing but distance upon time. So here distance d, it is the distance between A and B. Okay. And time taken, it is TAB. TAB means the time taken to go from A to B. And for this going from A to B, the speed is x kilometer per hour. So what will be this TAB? TAB means time to go from A to B. It will be nothing but d upon x. Okay, one can very well see. And similarly, what will be y? Y will be nothing but once again distance upon time. Okay, so distance is still same, but what will be time? Time I will denote it by TBA. So what is this TBA? The time taken from B to A. Okay, so obviously this will be nothing but d by y, sorry, d by y. So this is the time taken. Now, once again, what is the total distance covered? It is 2D. The total distance covered is 2D. And what is the total time taken? It is TAB plus TBA. Okay, so this is the total distance covered and this is the total time. Obviously, this will give us the average speed. This will give us the average speed for the whole journey. Okay. Now we have to merely plug in the values of this TAB and TBA. So what will be the average speed now? So what will be the average speed for the whole journey? It is 2D and here it is d upon x. Okay. And here it is d upon y, the values. So you can see here these values, they are here. So now it is nothing but 2D. Okay. So here actually we can take common D and 1 by X plus 1 by Y. Okay. So this D will cancel out. So even here it is 2. So here it will be XY will be the LCM. Here it will be Y. Here it will be X. And this XY, it can go in the numerator. So it will be 2 times XY upon X plus Y. Okay, so this is the derivation of this formula. Okay, so this is yet another very one of the very important questions based upon average. So without any stoppage, a person travels a certain distance at an average of 42 kilometer per hour, and with stoppages, he covers the same distance at an average of 28 kilometer per hour. So how many minutes per hour does he stop? Okay. So how many minutes per hour? Okay, means in 1 hour, how many minutes he stop? So what we assume, let the person travels for 1 hour. Let the person travels for 1 hour. Okay, because we have to. Why I am starting with this, that the person travels for 1 hour, because we have to calculate that how many minutes per hour does he stop. Okay, so that's why I'm starting with this. Now, since he has traveled for 1 hour, so without any stoppage, how much distance, means without any stoppage, how much distance he. So since the person has traveled for 1 hour, so without any stoppage, how much distance he will cover? The distance covered will be 42 kilometer. It will be 42 kilometer. And with stoppages, how much distance he will cover? It will cover, the person will cover 28 kilometer. Okay, since he has traveled for 1 hour. Now, what about this remaining 14 kilometer? This 14 kilometer. Actually, this 14 kilometer remaining, it is due to the stoppages. This remaining 14 kilometer. Okay. One can very well see that 42 minus 28, it is 14 kilometers. So this 14 kilometer remaining, it is due to what? Due to the stoppages. So that's why what will be the stoppage time? The stoppage time, okay. Once again, stoppage time, it will be the distance, okay, distance upon the speed, okay. Just like the same formula means actually this distance 14 kilometer. If stoppages are not there, if stoppages were not there, then this 14 kilometer, okay, he would have covered in 14 divided by the speed 42 kilometer. Okay, and that will give us our stoppage time. Okay, so obviously now distance is 14 kilometer and speed, what was the speed without stoppage? Okay, that is 42. Okay, so now it is 14 by 42, and this is obviously in hours. We have to convert it into minutes, so 42 into 60. Okay, so this will be 2 7 2 and 7 6, so 6 10 means 20 minutes. Okay, so here it will be none of these. Okay. Okay, so here this extra 14 kilometer, okay, which is yet to be covered if he travels with the stoppage. So this 14 kilometer, if stoppages were not there, then he would have covered with what speed? With speed 42 kilometer. Okay, means this remaining time means 14 divided by 42 means the distance remaining, which will be covered with what speed? 42 without any stoppage. Okay, so that will give us this thing, and that's why 20 minutes. So the stoppage time is 20 minutes, means the none of these option is correct. So here there are three numbers, say A, B, and C. Now second is twice the first and is also thrice the third. Means this B, it is twice the first and it is also thrice the third. And if the average of these numbers is 44, what is the largest number? We assume that the number C, let it be 1. Okay. Then obviously second, okay, it is thrice the third, means it must be 3. Okay, thrice the third, the second number. Okay. It must be thrice the third, means if C is 1, then this B will be, the second number will be 3. Now, the second is twice the first. So it is twice the first. So I must take A as 1.5. I must take A as 1.5. Okay, only then it will be twice of the first. Okay, so now here since this is the ratio among the numbers, and we have to convert into integers, so multiply throughout by 2. So here it will be 3, here it will be 6, and here it will be 2. Means the numbers, they are in this ratio. So what we say, what we assume, let the numbers be 3x, 6x, and 2x. The numbers be 3x, 6x, and 2x. So if we add these and divide by 3, this is the average of the numbers. The sum of the numbers divided by the number of numbers. And that is given to be 44. So we have to mainly solve this. So 6 plus 3, 9 plus 2, 11, 11x, that is 44 into 3. Okay. Please do not try to multiply 44 and 3. There is no need because one can very well see because this 11 will cancel out with this. So x will be nothing but 12. Okay. So if x is 12, what will be the largest number? Actually, the largest number is 6x. So it will be 72. Since x is 12, okay, so the largest number will be 72. Similarly, we can find the other two numbers also. Okay, so this is one way, and there is another way. If someone is not comfortable with this, then the second number, okay, it is twice the first number. Okay, and second number, it is also thrice the third number. We can go by this way also. Okay, so here now we have to mainly find out the ratio, the mutual or common ratio between A, B, C. Okay, so here B, the second number, it is twice the first number, and again B, this is the thrice the third number. And here since B is common, the B is common. So I will write B here, okay, in the middle, and I will write A here and C here. Okay. So now what is the ratio between B and A from here? If you see here, so the ratio between B and A, actually it is A ratio B. If you see here, it will be nothing but 1 by 2. The ratio between A and B, it is 1 by 2. Okay, from this equation, one can very well see. So here what I will write that B is 2 and A is 1. Okay, B is 2 and A is 1. Now similarly from B equal to 3C, I can write the ratio that C ratio B, the C ratio B, okay, it will be nothing but, so actually it will be 1 by 3. So once again, if B is 3, means B is 3. Okay, what will be C? C will be 1. C will be 1. Okay, so even here A ratio B means B is 2. B is 2. What will be A? A will be 1. So now we have these pairwise ratios, but we need the common ratio of these three numbers, mutual ratio. For that, I need this ratio to be same. This ratio should be same. So for that, what I do, I multiply this 2 by 3 and I multiply this 3 by 2. I multiply this 2 by 3 and this 3 by 2. So obviously here it will be common number, that is 6. Okay. So now what I do, I write 6 here. Now, since I have multiplied the upper ratio by 1, the upper ratio by 3 here. So even this one will be multiplied by 3. So here it will be 3. And this lower one, okay, I have multiplied here by 2. So even this one will be multiplied by 2. Okay, nothing. Since I had multiplied this 2 by 3, so even this one will be multiplied by 3. Since this 3 was multiplied by 2, so this one will be also multiplied by 2. So 3 is ratio 6 ratio 2. So you can see this is the same mutual or common ratio between A, B, and C. Okay. So even this technique, it is very important because what technique that if the comparison between two different pairs are there, the comparison between two different pairs of objects or things are there in which one object is common, one thing is common. Here B was common. Okay, so then sometimes we need the common ratio, the mutual ratio of all the three or four. Okay, so this is the way to find that ratio. Okay. And now here there is a similar question. So here Harish has twice as much money as Rohan. Okay, and Rohan has 50% more money than Anita. So here Rohan is common. One can very well see that Rohan is common. So here Rohan is common. So I will write the Rohan in middle, and here this side Harish, and here this side Anita. Okay. Now, Harish has twice as much as Rohan. So suppose Rohan has one unit, so Harish will have 2 unit. Okay, whatever it is there, or here it is money. So say Rohan has 1 unit of money, Harish will have 2 unit of money. And moreover, Rohan has 50% more money than Anita. Means here 50% we can write it as 1 by 2. We can write it as 1 by 2. So means Rohan has 50% more than Anita. So what is the meaning? The meaning is that if Anita has 2 units, okay, the Anita has 2 units, then how much units Rohan will have? The Rohan will have 2 plus 1, 3 units of the money. Please mind, this is important that Rohan has 50%, means 1 by 2 more than Anita. Okay, more than Anita. So if Anita has, means Anita has 2 unit of money. Here it is comparison with Anita. Comparison is with Anita. The Rohan is being compared with Anita. So this denominator, it corresponds to Anita. Actually, denominator always corresponds to the person or the thing with which the comparison is being done. Okay. So in a just rough way, that this two, it is corresponding to whatever which comes after than. So here, this is the rough sense that the denominator, it is corresponding to whatever comes after than. Okay. So if Anita has 2 units of money, then Rohan will have 3 units of money. Or one can go by this way also, that suppose Anita has X units of money. Anita has X units of money. Okay. So this is for Anita. Okay. So obviously Rohan will have actually X plus 50% of X, the 50% of X. So this will be X plus 50, 100 and X. So obviously this is 1 by 2, means it is X plus X by 2. So this will be 3X by 2. This will be 3X by 2. Okay. So if now one can see that what is this X? X, this was the amount of money, means X units with the Anita. Okay, X unit is with Anita, and Rohan, he has 3X by 2. Okay, means Anita has X unit of money, Rohan has 3X by 2 unit of money. So X we can cancel out, and this 3 by 2 means this 2, actually this can go to this side. So what it will give us? It will give us that 3:2, means Anita and Rohan, they have money in this ratio, 3:2, which is nothing but here. You can see. So now I need the common ratio. For that, what I do? I need a common number here. I need a common number. For that, I simply multiply this by 3. So here it is 3. So first I write 3 here. Since I have multiplied this one by 3, I have to multiply this 2 by 3 also. So 6:3. And this 2, it will be this one too, it will be as such. Okay. So this is the common ratio. The common ratio between Harsh, or not between, among. This is the common ratio among Harsh, Rohan and Anita. Okay. So now suppose they have 6X, 3X and 2X. This amount of money for each one. So this is the ratio of the money. Okay. So we assume that they have this one. Okay. So what will be their average? Average 6X plus 3X plus 2, sum of the money. And what is the number? 3, because total 3 in number. And here it is 110. So now it is nothing, 639 plus 2, 11x. Okay, that is 110 into 3. So what will be x? Here it will be 10 cancelled. So what will be x? It is 30. Okay, so Harish has how much? Obviously this 6, it is corresponding to Harish. So 6x means Harish has 6 into 30, 180 rupees. Okay. So Harish has 6x, means 6 into 30 means 180 rupees of money. Okay.